Yo, what's up, guys? It's Yujin Tang. So this module is going to be covering KNN, K nearest neighbors. This is a classification algorithm where you plot a bunch of points and then you classify new points by seeing which points they're closest to. And for this one, our hyperparameter, just like the k-means one, we have the hyperparameter of k. Unlike k-means, where k controls the number of centroids, or the number of clusters, the number of classes, here k controls the number of neighbors that it'll be closest to. So for example, in this example right here that I have on the screen, this green dot would be classified as a triangle if it were using 3 nearest neighbors, but if we were using 5, it would be classified as a square. So let's get into it. I'm going to show you kind of how to create the plots and visualize the plotting diagrams. I'm not going to do the test train stuff yet. I'm just going to show you how to kind of get started with this, okay? So basically the first thing we're going to want to do is we're going to want to import our libraries, as always, matplotlib.pyplot as plt, import pandas as pd. Oh man, pd, there we go. We're also going to want to import sklearn. What are we going to want to import? From sklearn, sorry. From sklearn, we're going to want to import datasets and neighbors, I believe. Neighbors, yep, there it is. And then we're also going to want to get PCA, and I promise I will make a video about PCA because it comes up too often for me not to make a video about it. Sk decomposition. PCA is a dimensionality reduction algorithm, and I'll put a dot plotting. Yep, import plot region. There it is. PCA is a dimensionality reduction algorithm, and I'll put a link to an article about PCA below. It takes like 5-10 minutes to read. You can get all of that. So what we're going to do here is we've just imported all the libraries we're going to need. So later I'm going to get a data set from sklearn, but the first thing we're going to do is we're going to produce our own data set. So let's import numpy as np, import random. So this is going to help us create our own data set. So what we're going to do is we're going to create a data set that's basically just it's going to be a blob, and half the data set is going to be zeros and half the data set is going to be ones. I'm going to produce x's, an x1 and an x2 variable, somewhere between uniformly randomly distributed between 0 and 1, and then I'm going to produce a y variable that's going to be 1 if x1 plus x2 is greater than 1, and else it's going to be 0. So how are we going to do that? Let's get into it. Let's just select contrived data equals this, contrived targets is empty lists. Let's do 100 samples. For I in range samples. You can also just do a range 100. You don't need the samples. We're just going to do x1 equals uniform or random. Sorry, random dot uniform 0 1. x2 is equal to random dot uniform 0 1 0 1. And then y is going to be equal to 1 if x1 plus x2 is greater than 1, else 0. And then we're just going to append our data, the x's and the targets. So contrive data dot append x1, x2, contrived targets dot append y. And for our example data, so this is the full example data. This is just going to be equal to np.array contrived data, and then np.array contrived targets. So what we're doing here is we're making our example data a list of these two arrays, and we're going to have to do an np.array form because that is the way that sklearn expects to see the data structured. So this is our example data. Now let's create a KNN function. So def KNN, and it's going to take the data, and it's also going to take a k. And here what we'll do is just x equals data 0. And this is also the way that sklearn returns their data when you call data sets, so that's why I'm creating it this way. Data, oh, wow, this typing is not good today. Anyway, KNN dot, no, that's not right, neighbors dot nearest neighbor, there it is, and n neighbors equals k, and then we're going to fit x, and then we're, sorry, xy, probably, yeah, xy. You need the x and the y. And then we're just going to plot the decision regions. Plot decision regions based on k, so x, y classifier is equal to KNN. And then we'll just do, oh, not plot, it should be PLT. Oh, no, that's right. Yeah. Plot dot x label is just going to be x1, and then dot PLT dot y label is going to be x2. And then PLT.title is going to be KNN with k equals whatever k is. I don't know if we actually have to turn it into a string here, but let's not get an error, right? And then this is our KNN function. Now we just call it KNN example data and 5. Ooh, what's going on here? Nearest neighbors has no attribute predict. Oh, that's right. This is not right. This should be kneighbors classifier. We're creating a classifier, right? And there we go. So this is what KNN on a contrived data. So this should be just like a straight line. And it's not, but it's pretty close. So yeah, that's what KNN looks like on a contrived data set. Now let's see what happens if we get KNN on a, I'll just leave this here actually, KNN on a loaded data set. So let's load a data set. How are we going to do this? Data sets dot load. Let's load the wine data set, yeah. And let's get it back in XY form. Yep, equals true. So this is going to make it so that our data set looks exactly like this kind of example data. It's going to be an array of x and an array of y inside of an array. And then, oh yeah, okay, so let's extend our KNN thing. So we'll say PCA equals false. But if we, so sets the default PCA equal to false. So here what we'll do is if PCA x equals PCA and components equals 2 dot fit, or is it fit transform? I think it's fit transform x. Yeah, and you'll see why we do this in a moment. Actually, I'll just show you why we do this. Let's print out data dot shape. Sorry, that's the x value, data 0 dot shape. So that's 178 by 13. And obviously, if we're plotting on a two-dimensional graph, having 13 dimensions is not helpful for us. So let's see. I'm gonna use the hyperparameter tuning. I'm gonna show you how this works, right? So for I in, so let's check out what it looks like from 5, 10, 25, and 50. Let's plot our KNN sample. So KNN data I, and then we'll do PCA equals true. Oh, I have to, haha, yes, I have to fix this first. Yeah, okay. I have to run that, and now we run this. So KNN equals 5 looks like this. KNN equals 10 looks like this. KNN equals 25, and KNN 50. So here we see, 5 is kind of like jaggedy, but it's because of the way that the wine data set is actually structured that, we see a lot of kind of weird outliers with the triangles, and same with the 10, right? And a lot of weird outliers with the circles and stuff. So at 25 and 50, we pretty much see these are the decision boundaries for if we were to generally classify, if we wanted like a very general classifier and we just want to throw a point and be like, all right, where's the point? We can just base it off x1. It's basically entirely based off x1 here, right? And that's, once we do PCA, x1 becomes the axis which accounts for most of the variance. So that's why it's like that. I think probably like 5 or 10 are going to be better classifiers. It's because we have a bunch of like outliers with the triangle looking data. And another comment about this data is just like it's wine, so like nobody knows anything about wine anyway. So of course it looks weird. Anyway, yeah, that's all there is to KNN. That's all you need to know to get started with decision regions and start playing around with KNN on your own. If you have any questions, please drop them in the comments below. Thanks for watching. If you enjoyed this, please give me a like, give me a follow, and I'll see you guys next time.